Okay, so in the homework video last night, I said when we solve exponential equations that there's two ways that we can solve it. So I said last night that the first way was by changing the base. The second way is using logs. So this is going to be solving exponential equations. So we're continuing on those notes. But now we're working with the second way, which is using logs. So let's say we have the problem 6 to the 2x plus 1 equals 13. If I looked at my chart, 6 and 13 are definitely not in the same column. There's no way to make the, well, you could make those the same base, but they would be decimal bases, and it would be very hard to find them, okay? So anytime you have a problem like this, you are not going to think about changing the base because it's not worth the time, okay? The first step of the problem depends on how you like to think about this, okay? So this is an exponential form. The variable is trapped in the exponent. One way to think about it is you can say, I'm going to Tootsie Roll or Scorpion or Cloud or Circle Thingy or whatever to convert it into log form. That's one way you can think of the problem. So I'm going to go ahead and write that out first. That would mean that we have log base 6 of what? All right, of 13 equals 2x plus 1. So that's one way of showing your work for the first step. The other way of showing your work for the first step is to truly think of this as like an inverse process. So I'm going to go ahead and rewrite the problem over here just so you can see me doing the inverse. The opposite or the inverse operation of exponential form is log. So technically to undo this, I would log base 6 the left side and log base 6 the right side. And when I log base 6 an exponential problem that has a base of 6, these are opposites and so they cancel each other out. So log base 6 and a base of 6 cancel. Okay? Either way you think of it is totally fine. They are both accurate. I've just noticed that some students pretend they prefer to log each side. Other students prefer to Tootsie Roll. It accomplishes the same thing. All right? Yeah. So maybe you'll remember that better. Yeah. All right? Okay. So from here, how do we get the x alone? We subtract the 1 over, right? We want to get the x alone, so we're going to subtract the 1 over. So we'll say that log base 6 of 13 subtracting the 1 equals 2x. And then what do I do? Divide by 2. So log base 6 of 13 subtract 1 all divided by 2 equals x. So this is considered a solution. It's an exact solution because I didn't plug it in my calculator. I haven't rounded anything. So this is like the perfect exact answer. It is possible on a multiple choice test to have you do a problem like this because then you have to know how to do it by hand. You can't like cheat and graph it and do like a little shortcut to solve for the equation. You have to know what you're doing, okay? Once you have this, if you want to have the approximate answer, you can go ahead and plug it into your calculator. So I'm going to hit alpha y equals so that I can plug it in like a fraction. And then to get log base 6, I have to say math and then up, up. So I have log base 6. The 13 is in the parentheses. The minus 1 is not. The log only happened to the 13. The minus 1 came after that. And then I've got the 2 on the bottom. So my x value here is 0.216. Two answers, exact answer, approximate answer. And then if you want to go back and check it, you can go ahead and store that as x. And then for the original problem, you could say 6 to the 2x plus 1 and verify that it equals 13. And it does, so that means we got it right. How do we feel about that process? Okay, all right. Let's try another one. This one, we're going to say 12 equals e to the negative 6x minus 2. So what is your first step? We can do something before we change it to log form. Add the 2. Okay, so that's an easy thing to take care of. We'll add 2 and add 2. So 14 equals e to the negative 6x. And then this is the part where we say we have an exponential problem and the variable is trapped in the exponent. So do you guys want to Tootsie Roll the problem, or do you want to log each side? Tootsie Roll? Log? Okay, I'll go ahead and write both. So if you do the Tootsie Roll process, you would say, I'm going to have a log, and the base of that log is going to be e. So log base e of 14 equals negative 6x. What is log base e actually? ln. So that means we have ln of 14 equals negative 6x. If you don't like the Tootsie Roll idea, if you would rather do the opposite operation to both sides, we can go ahead and do that as well. Now, I do have some students who just say log base e, because it seems more consistent if you compare it with this problem. Some students just memorize that ln is what undoes an e, so it's up to you. Would you guys rather write log base e, or do you want to write ln, ln? ln. So we're going to say ln the left side, ln the right side. On the right side, ln and e are opposite, so they cancel each other out, where they are inverse operations. So ln of 14 equals negative 6x. So either way, we have the same problem. And then what do we do after that? Divide by negative 6. So x equals ln 14 divided by negative 6. And it's not just the 14 that we're dividing, it's the entire problem. So this is considered to be the exact answer. The approximate answer, I'm going to do alpha y equals, so I can type it in as a fraction. The ln button is right underneath your log button. So right down here. So ln 14 divided by negative 6. If we have 439 followed by an 8, what's our new decimal? 440. So 439 rounds up to 440. All right. So there's that. And then if I want to check my answer, I can go ahead and store that as x. And then I can type this in. Second ln to the negative 6x minus 2 equals 12, so I know I got it right. Okay. I'm going to go ahead and let you guys practice for a little bit. This is the back side of the worksheet. The first 4 problems look like this. The second 4 problems are a little bit more difficult, so I'm going to go over another example with you in about 15 minutes. Okay? What do the instructions on the paper say? I probably have both answers on my sheet, is my guess.
They say round.
They say round. So if they say round, it means I want you to plug it in and get the decimal. So before I do another example for your notes, I want to focus a little bit on how to start number 6 and number 8. So if you look at number 6, we kind of have this weird thing going on where we have a bunch of, we have the 5 multiplied by something in front, and we kind of would know how to handle that if this just said a number on the other side, right? So if it was kind of like number 1, then we would know, oh, just divide the -6 over and you're good to go. On this one, it's a little bit more confusing because you do have that extra exponent there. But if you guys notice, these have the same base, which means they can be put together. Okay, so I'm going to go ahead and divide by 5. And write small when you do this because these take more space. Or do them on a separate sheet of paper. These ones do take more space. So we have 12 to the b plus 8.3 equals, this 5 on the bottom has an exponent of what? 1. So anytime we have something that doesn't have an exponent written, that exponent by default is 1. How do you combine bases? So we know it's the same, so we can combine them. How do you combine your exponents? You subtract them. So this is 5 to the b minus 1. Okay, so I'm not going to do any more of number 6. I'm going to leave it just like that. But now we have it, so we've got bases on each side. All right, look at number 8. We're going to do the same thing. So we're going to divide by 3, divide by 3. I've got 16 to the k plus 2 equals, that's a 1. So what should I have on the right side? Yeah, 3 to the 5k minus 10, right? So 5k minus 9, and then we'd be subtracting that 1 off the end. Okay? All right, we're going to pause on the worksheet for now. We're going to go ahead and get our notes back out. All right. So for a problem like this, thinking about the Tootsie Roll doesn't really work out. Thinking about doing a log base 3 on each side is kind of weird because it would cancel on the left side but not the right side. A log base 4 would cancel on the right side but not the left side. So for problems like this, where you have two different bases that cannot become the same thing, and you have exponents for both pieces, they have a special process. And for that special process, you can use ln each side, you can log each side, you can log base 94 each side, you can log base 5,000 each side, you can do any type of log you want. People typically do a regular log, that means a log base 10, or an ln. They do that because it's easy to write and it's easy to type into your calculator, okay? So would you guys rather do log or ln? Log. Okay. So what we're going to do is we're going to log each side. So I'm going to write log of 3 to the 2x minus 5 equals log of 4 to the negative x plus 4. So I did the same thing to each side. My next step is to use properties of logs. I have exponents here. What can I do with exponents? Anyone remember that property? Yeah, you move them to the front. So we're going to take this whole exponent, we're going to move it to the front. We're going to take that whole exponent, we're going to move it to the front. So since the exponent has multiple terms, you do have to put it in parentheses. These problems look a lot worse before they get better and you solve them. The equations look a lot harder than they are when you're done, but the problems all work out kind of the same, so the process is nice because it's repetitive. It's the same every time, all right? Okay, what do we do to get rid of parentheses? Distribute, yeah. So we're going to take that log 3, we're going to distribute to both terms. So the way that I write it is I say 2x log 3 minus 5 log 3. And then I have negative x log 4 plus 4 log 4. There's a little 4 right there. Can you see it? I missed it. All right. From this point, we're thinking of this as like, this is a regular equation. It just has terrible decimals. If we were to plug everything into our calculator, we would have lots of decimals all over the place, okay? So it's just like a normal equation, though, where our goal is to get the x's to one side and the numbers to the other. So we have an x right here and an x right there. We want those both on the same side. So I'm going to take this chunk right here and I'm going to add it to the left, because that's going to get my x's to the same side. So I'm going to keep the 2x log 3 and I'm going to add x log 4 to the left side. Okay, so I've got 2x log 3 plus x log 4. And that's going to be the only thing I'll have on the left side because I'm getting my x's to one side. Okay? So that means that this part right here that does not have an x in it, I want to move over to the right side. So I'm getting my x's on the left side. Anything without an x, I'm moving over to the right. So this one I just moved. I'm going to leave the 4 log 4, and I'm going to add 5 log 3 to the right side. So keep 4 log 4, add 5 log 3. My next step on the side that has the x's is I'm going to take the x out of each term and I'm just going to write the leftovers. So if I take out that x, that gives me 2 log 3. If I take out this x, it gives me log 4. And now to get the x alone, we just take this whole set of parentheses and we divide it over to the right side. So I get x equals 4 log 4 plus 5 log 3 divided by 2 log 3 plus log 4. So this is the exact answer. And then I can plug it in my calculator to get the approximate answer. You can come in. Perfect, so you can just set it right here. So we used log, which means we don't have to do math and then up. We can just use the log button. So I've got 4 log 4 plus 5 log 3 divided by 2 log 3 plus log 4. All right, let's go back to your worksheet and we can do one of the ones on there. So 5, 6, 7, or 8, which one would you guys like to do? 5 and 7 are going to be a little bit easier because the exponents are a little bit more simple. Do number 8. Okay, let's do number 8. So, since we did log last time, I'm going to go ahead and force you guys to do ln this time. So we're going to go ahead and we're going to ln each side. So I'm going to have ln of 16 to the k plus 2 equals ln of 3 to the 5k minus 10. So we logged each side, because ln is still a specific type of log. So we logged each side. What do we do with the exponents? We move them to the front. So we have k plus 2 ln 16 equals 5k minus 10 ln 3. How do we get rid of our parentheses? Distribute. So ln 16 is being multiplied by k, ln 16 is being multiplied by 2, and then ln 3. What is our goal at this point? Get the k's to one side. So the k ln 16 is already here. I'm going to go ahead and take the 5k ln 3 and I'm going to move it to the left side. Okay? So k ln 16 stays, minusing this one over. So I moved this one to the left side. On the right side, I still have negative 10 ln 3. And then what else do I want to do? Yeah, take the 2 ln 16 and subtract it over. Then, what do I do with the k's on the left side? Take it out. So it looks crazy, but do you notice the steps are identical? We're not doing anything different. Exactly the same steps. And what's the very last thing? Take the whole parenthesis, divide it over. Okay? So this is an exact answer. If you were to type this in using ln's, you would get a decimal. If you were to type this same answer in but use logs instead of ln's, you would get the same decimal. If you use log base 5 instead of ln, you would get the same decimal. So it doesn't matter what type of log you use, it will always give you the same exact, or the same approximate answer, okay? And the only difference in your exact answer would be which type of log you used. You could even use log base pi if you were feeling snarky. Anybody? No? I feel like that'd be pretty legit. Typing it would be obnoxious, but no? All right.